Dear students, welcome back to our continuation of our discussion in the case of subcooling of liquid refrigerant using the vapor refrigerant. So in the just a previous session we discussed how we can go for subcooling of a liquid refrigerant using the vapor refrigerant. A little more discussion is pending in this section. So we stopped it here by discussing the pH diagram. Okay, we in the last session we discussed how we can draw the pH diagram for the subcooling of liquid refrigerant using the vapor form of the refrigerant. Okay, so then we have discussed that the heat rejected by the liquid refrigerant during 3-3 will be the heat gained by the vapor refrigerant during 1-1, producing this superheating. Okay, so what is the how we can discuss the effect in the refrigeration effect, or how this system that is this subcooling of this liquid refrigerant using vapor refrigerant, that is this system is affecting the total refrigeration effect of this refrigerator equipment. Okay, so now let us focus on our TS diagram and pH diagram, especially the pressure enthalpy diagram. So because pressure enthalpy diagram is more useful when we are discussing the refrigeration terms. Okay, so now regarding the refrigeration effect, so what will be the refrigeration effect without the subcooler? So without the subcooler means the subcooler is nothing but the heat exchanger here, where the low temperature, low pressure vapor form of the refrigerant is going to absorb heat from the high temperature, high pressure liquid refrigerant coming out from the condenser. Okay, so this heat exchanger is nothing but the subcooler, which is producing the subcooling of the liquid refrigerant using the vapor refrigerant. There is another term for this subcooler, that is nothing but the liquid suction heat exchanger, that we discussed in the last class. So suppose there was no such a subcooler over here, what would have been the effect in the what would have been the change happening to the refrigeration effect? Now let us focus on that. In the pH diagram, 4, 1-1, 2, 2-3-3, 4. That is the representation of this system in the pH diagram. So suppose there was no such subcooler over here in the system, this is the pH diagram would have been like this. Some point A, 1-1, 2, 2-3, and straight away going to A, point A. So as we discussed in the last session, 3-3 was our subcooling effect, or the subcooling of liquid refrigerant using the vapor refrigerant. Suppose there is no such subcooling happening in our cycle, or there is no such subcooler arrangement, or there is no such that is suppose there is no such heat exchanger placed over here, or there is no such subcooling like 3-3 happening. So the cycle refrigerant would have been stopped at 3- after coming out of the condenser. Then straight away it would have moved on to the expansion valve. That is, the expansion valve process would have been 3- to A. So point A is nothing but some arbitrary point, or some assumed point which is not actually present in our system. But suppose we are not using the heat exchanger, point A will be representing the exit of the expansion valve. Okay, so in such a case, without the subcooler, the refrigeration effect would have been H1- minus A, HA, or H1- minus HA, enthalpy difference from 1- to A. That is, if there was no such subcooler, there will not be any superheating also. So when we compare with a standard vapor compression refrigeration system, the refrigeration effect will be only this much, 1- to that is H1- minus HA, or A to 1- would have been the only refrigeration effect in the case of a standard vapor compression refrigeration system. But with this subcooler, that is when we are introducing such a subcooler like this in the heat exchanger, suppose we are when we are purposefully creating such a heat exchanger over here, what would be the effect in the case of refrigeration effect? With a subcooler like this, the new refrigeration effect will be H1 minus H4. Okay, H1 minus H4, which is definitely higher, which is of a higher value than H1 dash minus HA. So what would be the case? COP will be increasing. Why? COP is given by this refrigeration effect divided by the work done by the compressor. But wait, what will be the case of work done by the compressor in this case? So that is written over here. The compressor work will increase because we need to compress the superheated vapor, okay, which may imply that COP will decrease. That is, here we are going to so that is here this compressor is at the inlet of the compressor, the nature of the refrigerant is superheated vapor form. Okay, so it is the superheated vapor form of this refrigerant which should be compressed by the compressor. Okay, so this compression process or the main compressor working is happening exclusively in the superheated vapor state. That is, at the inlet of the compressor itself, the refrigerant is in superheated vapor state. It is again getting compressed to a still higher pressure and temperature range of the superheated form of the refrigerant. So it is very difficult to compress a superheated form of the refrigerant or any material. Okay, so definitely the compressor work will be increasing. The compressor work will be increasing since it need to compress the superheated vapor. Okay, but we may think that the COP will decrease because this compressor work is coming in the denominator for the COP expression. But the COP is given by refrigeration effect divided by the compressor work. So here we have considered the with this subcooler, the refrigeration effect is very much increasing, that is H1 minus H4. It is a very high value compared to H1 dash minus HA. So this refrigeration effect is so high that the even though at the denominator, that is the compressor work is coming, even though it is increasing, the overall value of that ratio, that is COP, will be definitely increasing. So by implementing an additional heat exchanger like this, we are going to subcool the liquid refrigerant coming out from the condenser, and as a result of this subcooling effect, we can go for a very large increase in the COP of this refrigerator. Okay, so in a way we are improving the COP of the refrigerator system by implementing subcooling of the liquid refrigerant using vapor refrigerant. Okay, so what I recommend is that all of you dear students, you draw this diagram and also the associated TS diagram and pH diagram. Then you yourself write down what is the refrigeration effect without subcooler and with subcooler. Okay, so we will be requiring this when we are solving the problems. Okay, so thank you.